Things are about to get a lot quieter on the front of the Russo-Ukraine war. Recent footage has revealed that Ukraine has developed what appears to be a genuine stealth attack drone. It's been dubbed the Ghost in the Sky, which combines cutting-edge aerodynamics with the country's penchant for using evocative names for drones meant for nighttime operations. This isn't another converted commercial quadcopter strapped with explosives. What we're seeing represents a significant leap in Ukrainian drone technology. We've gone from small drones and relatively simple bomb carriers to a purpose-built, jet-powered stealth platform that borrows design principles from the most advanced stealth aircraft, while maintaining the philosophy of expendability, mass production, borderline reckless need for innovation, and reusing existing resources, which was what made Ukrainian drones so devastatingly effective in the first place. Note that the limited information available suggests these mystery drones are currently being field-tested in small numbers, likely as Ukraine evaluates their effectiveness against Russia's air defense and counter-drone operations. But even from these small glimpses through just a few up-close shots of downed drones, we can surmise that they might just push the envelope of drone warfare yet again. So let's dive into what makes these drones tick, how they compare to previous models, and why it matters. The first thing that pops out about the stealth drone is how it doesn't look anything like typical Ukrainian battlefield innovations. There are no crude modifications, duct tape ordnance or cameras, and jerry-rigged components that were given in their earlier drone programs. Instead, what is shown is the image of a sleek aircraft that seems like straight out of the minds of aerospace engineers at Northrop Grumman with boundless material options and budgeting. More specifically, the drone features a relatively low-profile delta wing configuration, notably with canted vertical stabilizers. The delta wing was obviously chosen to minimize radar cross-section and harkens back to the effective designs of modern military aircraft from the 1970s onwards. The lack of right angles deflects and scatters radio waves that traditional radar-based air defense systems use to detect aircraft. With less of the originating wave reaching the receiver dish, the software reports it as having a much smaller size than it actually does, which leads to it being less visible or disregarded entirely. The canted vertical stabilizer here is also similar to classic stealth aircraft designs, which either use dual canted vertical stabilizers, see the F-18 or F-35 fighter jets and even the F-117 stealth fighter, or completely remove them in the case of the B-2 Spirit and the upcoming B-21 Raider stealth bombers. The actual hull is similar to a stealth drone reported in 2024, where the presence of a vertical stabilizer is likely a design concession to ensure the aircraft actually has enough flight aerodynamics and stability. The similarities in construction suggest that the new design might be a new iteration of an older design that has obviously been in active testing for at least a year and a half now. The grey or black finish, which is difficult to discern exactly due to reflection, is also a relatively recent innovation for drones. It's likely been used because it can absorb rather than reflect electromagnetic energy across multiple spectrums. This is evidenced in the few images that we've seen of the aircraft. Every surface flows smoothly into the next, with pretty much no separation between the hull, the wings, and the tail section. At less than 10 feet in length with an 8-foot wingspan, considering that social media reports it being smaller than its predecessor, this platform sits in the sweet spot between detectability and capability. Its size is much smaller than conventional stealth drones we've seen from the US or Russia, which typically start at 14 to 15 feet in length and have much larger wingspans. At the same time, the drone is large enough to carry explosive payloads that can damage or destroy tanks, radar batteries, or possibly even buildings. The actual construction of the drone is unknown as of the making of this video, but an earlier model might give us some indication. Based on a limited analysis of publicly available information, the drone likely has no reinforced framing, instead using carbon fiber and fiberglass throughout. This is one of the most likely combinations that ensures a balance between strength, durability, and flight worthiness. These composite materials on the surface are naturally less reflective to radar than metal construction, contributing to the overall stealth profile. More importantly, for Ukraine's production capabilities, composites can be manufactured in distributed facilities without the massive industrial infrastructure required for precision metal aircraft construction. This is unlike the previous design, which has been suggested to have a wooden frame, which could increase its overall weight. Of course, the new model could still have some sort of framing, but limited information and a purportedly weaker propulsion system are all pointing away from that hypothesis. And propulsion is where we see the biggest difference and innovation between conventional drones and earlier models. Previously, drones would use electric motors to power propellers that would allow the drone to fly relatively slowly in the direction of the target, at least by modern aviation standards. But early footage suggests that the mystery drone is powered by a US-made SW-140B micro-turbojet engine. This is more than simply swapping out the engine, it changes how the entire drone operates and even looks. Jet propulsion immediately solves several critical problems that can plague propeller-driven drones. The elimination of large, spinning propeller blades dramatically reduces both radar signature and acoustic detectability. Propeller tips moving at high speed create distinctive radar returns and a characteristic noise that trained operators can identify and, as a result, launch countermeasures, most likely drones of their own. But these drones would be stymied by jet propulsion's other benefit, speed. Where propeller drones typically cruise at 30 to 50 miles per hour, a jet-powered platform can potentially reach speeds exceeding 200 miles per hour. This velocity doesn't just get the drone to its target faster, it prevents it from being targeted by traditional means. Russian air defense and drone operators, who could be accustomed to tracking and intercepting relatively slow-moving targets, suddenly face threats crossing the active front line in seconds and going deeper than ever before. Simple drones and gunfire are much less likely to be effective when your target just zips by unannounced and silently. However, there are problems with jet propulsion. Turbojets produce much more heat, which is another signature that dedicated infrared detection systems track, and is potentially offsetting some stealth advantages. The fuel consumption is also dramatically higher than electric systems, limiting operational range and loiter time. For the heat signature, the lack of a visible engine on the photo suggests the jet is located firmly inside the framing, which is one of the hallmarks of stealth design. However, modern jets also use special cooling systems where valves also mix external cold air with the exhaust to cool it down before it exits the plane. In a small platform like a drone, the latter is simply unlikely and is instead compensated by using a relatively small engine that has a fraction of the power output and subsequent heating. One of the more critical downsides of using jet propulsion is its added complexity and relative novelty. Ukrainian workshops have practically mastered the art of modifying commercial quadcopters to the scale where they've built dedicated copter-based models like the Baba Yaga. But integrating and maintaining micro-turbojet engines requires entirely different technical expertise and supply chains. The engines aren't exactly available off the shelf and are not nearly as abundant as simple first-person view drones that can be used for modifications. The entire fuselage needs to be built from scratch, which goes to show just how much Ukraine could accomplish by delivering another new drone to the front line in under 2 years. The SW-140B represents a sweet spot in micro-turbojet technology. It's significantly more fuel-efficient than earlier generation engines while maintaining the thrust-to-weight ratios necessary for high-speed flight. Unlike larger commercial engines, the SW-140B was specifically designed for unmanned operations, particularly for model aircraft enthusiasts, offering reliability and simplified maintenance that battlefield conditions demand. The engine requires a relatively small fuel source, a starter battery, and a rudimentary control system to be operational. This choice of engine appears to be the result of Ukrainian engineers learning from their earlier experiments. The model in 2024 seems to have used the more readily available engines like the German-made JetCat P400 Pro. However, the JetCat engine costs 6 to 7 times more than the SW-140B, which would make it one of the costliest components of the entire build. This would go against the philosophy of building cheap frontline drones that are hopefully durable enough for multiple uses but ultimately disposable. Additionally, the German engine consumes fuel at rates that would severely limit the drone's operational range and mission flexibility, which are still subject to debate. These differences are particularly critical for Ukrainian operations. While the JetCat might offer much higher performance in laboratory conditions, its appetite for fuel would require either larger fuel tanks, which add an overall larger hull to double up on the weight requirement. The P400 has 425 newtons of thrust, while the SW-140B only has 140, suggesting that the hull modifications have resulted in sufficient weight shedding to justify using the weaker engine. As such, the engine is likely just powerful enough to let the drone carry its payload, whether it's an explosive or a surveillance package, to the destination and possibly even back. Despite the revolutionary airframe and propulsion system, Ukrainian engineers didn't seem to improve on weaponization. With no notable weapons systems shown on the images, we have little more to go on than using previous testing equipment as the base. And in the previous drone, Ukraine adapted the same proven warheads that have devastated Russian armor across hundreds of documented strikes. The drone appears capable of carrying the same RPG-7 warheads, RKG-3 anti-tank grenades, and custom-manufactured shape charges that have made Ukrainian FPV drones so effective. This represents classic Ukrainian battlefield philosophy. If it works, keep using it until something better comes along. This payload compatibility offers several crucial advantages. First, Ukrainian forces already understand the effectiveness of these munitions against various Russian targets, so you can deploy the exact ordnance depending on what you're hunting on any given mission. Secondly, logistics chains for explosives and warhead components are already established, relying on the country's extensive stockpiles of Soviet-era warheads that are now starting to get used up and restocked by Western shipments. More importantly, drone operators don't need to retrain on new weapon systems. They can focus on mastering the platform's unique flight characteristics and stealth capabilities to plan new approaches and conduct different types of missions in the same airspace. While we don't have exact details of the payload capacity, it's likely going to be similar to what we've seen from other successful Ukrainian platforms, just enough to carry tank-killing warheads into a defended airspace. Much like actual model aircraft, the drone seems to be a simulacrum of a smaller stealth bomber. It's built to deliver precisely targeted strikes against high-value targets that are protected by conventional detect and intercept methods looking for slow or large objects. A fast-moving small drone would be a literal blip on the radar that would quickly prove deadly. To understand exactly why we're raving about a drone that looks like a stealth bomber that we have 3 pictures of, we need to compare Ukraine's approach with the stealth drone programs of major military powers. And to do that, all we have to do is go to Russia and the US. Russia's S-70 Okhotnik B, meaning hunter, represents the traditional approach to stealth drone development, a massive, 60-feet flying wing designed as a complementary aircraft for multi-role fighters. On paper, it's formidable, with a stealth design that supposedly matched Western contemporaries. At least it appeared so until images were obtained of Russia needing to destroy a drone gone rogue, and Ukrainian forces shooting one down to reveal the reality behind the propaganda. The recovered wreckage showed visible panel gaps, metal fasteners, and construction quality that made its stealth claims laughable. America's RQ-170 Sentinel went in a similar way but pushed the constraints of an unmanned aerial vehicle to its limits, integrating genuine, cutting-edge stealth technology in a platform designed for deep penetration surveillance missions. Ukraine's mystery drone occupies an entirely different category. It's not trying to be a reusable intelligence platform like the RQ-170, nor is it attempting to match the theoretical capabilities of the Okhotnik B. Instead, it represents something potentially more dangerous, a stealth-ish platform designed from the ground up to be expendable. This philosophical difference matters enormously in practical terms. Russia needs to perform various cost-conscious calculations when it comes to risking its few prototypes of Okhotnik B in actual combat in a war that has already lasted for too long by modern standards. The US carefully manages the deployment of virtually irreplaceable Sentinels to avoid repeating the scenario of one being downed and its technology emulated by foreign actors, such as what happened in Iran in 2011, which is why the advanced drone is still among the country's top secrets. In contrast, Ukraine appears to be developing stealth drones specifically designed to be lost in combat. The goal isn't to bring them home. All they have to do is reach their targets and go boom. The emergence of Ukrainian stealth drones comes at a moment when Russian air defense systems are showing increasing signs of strain and failure. In May, Ukraine destroyed a Russian Buk M3 anti-aircraft missile system and a Uragan-1 multiple launch rocket system (MLRS). In early August, Ukraine struck another vital victory by destroying an S-300 air defense system in occupied Zaporizhia. Around the same time, Iran's stockpiles of S-300s imported from Russia proved to be practically useless when tested against Israeli and US forces. Traditional air defense networks like Russia's S-300 system and its more advanced successor, the S-400, were designed during an era where aerial threats were large, expensive platforms worth engaging with expensive interceptor missiles. The mathematical equation was straightforward: spend roughly $1 million on a missile to destroy a $100 million bomber or fighter jet. Even when Russia developed the S-500, the same concept rang true. Intercepting a stealth aircraft was worth the long-term investment in radar systems and one-off costs in a missile. The drones completely invert this equation. If a drone costs somewhere in the range of $20,000 and even up to $50,000, throwing a missile at it doesn't make sense. Scale this across hundreds of drones and this traditional method doesn't work. Instead, electronic countermeasures, drone-to-drone warfare, and short-range engagement options like traditional gunfire have become go-tos for trying to keep up, and both sides have leaned heavily into detecting drones and then deploying jammers to disable them before they can reach their intended target. The stealth characteristics of this new Ukrainian platform aim to strike at the weaknesses of these new defenses. Traditional air defense is seldom used to detect drones. Instead, Russia relies on smaller, shorter-range radar for timely engagement. And these systems were built to intercept drones that constantly relay electromagnetic waves as part of their control signaling, or have larger radar cross-sections due to bulky constructions both horizontally and vertically. The streamlined design of the drones can bypass the radar portion of the system. Its design could allow it to operate autonomously using inertial and GPS positioning, reducing the need for constant communication with an operator and enabling it to complete its mission even without continuous remote control. And the jet propulsion adds an element of speed that allows the drone to cover more ground and prevent traditional drones from catching up. As such, the new systems are also meant to further Ukraine's psychological warfare. Russian operators who've spent months tracking and engaging relatively predictable drone threats suddenly face platforms that appear and disappear from their screens unpredictably. The added stress of potentially missing a stealth penetrator when trying to avoid the abundant FPV drones can quickly lead to Russian soldiers retreating or surrendering to incoming Ukrainian forces. And the drone having increased stealth capabilities makes it much more effective at turning the economic tide of war. Despite being relatively cheap to manufacture or retrofit, FPV drones suffer from terrible loss rates. At one point, around 5 units were needed to hit a target. A report by Wired claimed that Ukraine managed to score a significant victory by increasing the success rate of higher quality drones from 30 to 70%. This results in the seemingly inexpensive drones eventually adding their costs to breaching the six-figure range common for actual, high-quality models or long-range drones used in the war. If the stealth drones turn out to be effective, Ukraine can divest some of its resources from FPV drones to regular stealth drone production. After all, if one stealth drone can do as much as a few FPVs or even more advanced models, the added cost would very well be worth it. This doesn't necessarily mean Ukraine would slow down its rate of attack. Instead, it potentially makes every attack more likely to succeed, giving Ukrainian operators more confidence to be bolder and more innovative in their approaches. But let's go over the production number. Ukraine has scaled FPV drone production to over 200,000 units monthly, but the advanced platforms like long-range strike, surveillance, or these new stealth models are a bit more than a rounding error when compared to that figure. For example, around 30,000 bomber drones like the Baba Yaga multiple bomber drones were produced throughout 2024. If the figures double, we're still looking at only 60,000 bomber drones, which would likely cover the new stealth category as well. However, it's likely that the actual number of stealth drones will reach high triple digits in 2025. If they're being largely absent from major news reports from either side of the conflict is any indication. Of course, they are perhaps being used for high-priority targets and are mistaken for another system, or covered up by the Russian media to avoid scandalous reports. Either way, the stealthy approach likely won't overturn entire stratagems, but instead become a part of a tiered system. In that system, conventional FPVs are used for saturation attacks and frontline monitoring. Long-range models are used for destruction of faraway targets, and stealth platforms are used to detect and abuse holes in systems that are over-engineered for existing threats. The broader implications of Ukrainian stealth drone development extend far beyond the current conflict. What we're witnessing is a small country being able to become one of the forerunners of modern warfare and reaching production and innovation capabilities that were previously exclusive to superpowers with massive defense budgets and decades of research programs. The combination of commercially available micro-turbojet engines, widely accessible composite materials, and open-source stealth design principles means that Ukraine's only real barrier to entry to warfare is how many people and how much money it can throw at solving a problem. Then, iterations of designs can be tested on an actual battlefield against real opponents to further improve. We're already seeing this happen when two modules built along a similar timeline are as different as the entire fighter jet generations that took 2 decades to develop. Which leaves us to wonder just how much we haven't seen yet from Ukraine's arsenal. Perhaps the few images that we have now are already going to be obsolete in just a few months, and there's another, better, faster, stealthier model on the horizon. Thank you for watching, and if you want to find out more about Ukraine's drone industry, check out this video. And to stay up to date with the developments in the war in Ukraine, but also on global geopolitics, subscribe to The Military Show for daily videos.